Hello, star people. Welcome. I'm Deborah Bird. Today we've got something really interesting in the sky. This is an animation, but on February 17th, we'll have the real thing. It'll be 2026's first eclipse, a ring of fire or annular solar eclipse happening over Antarctica. Here it comes. Yay. Okay, and we also have an astronomy fact check for you coming up. Images on social media are claiming a six-planet parade on February 28th, but is that true? Earthsky's Marcy Curran will be here to slow it down and take a look at what's really happening. Okay, let's jump in. First, the solar eclipse. In a total eclipse, the moon covers the sun completely, the sky darkens, and the sun's wispy outer atmosphere, or corona, comes into view. But in an annular eclipse, the moon is too far away to be large enough in our sky to cover the sun. So the Earth, Sun, and Moon will line up perfectly on February 17th. But at mid-eclipse, the sun's surface will make a ring around the moon. The word annular comes from the Latin word annulus, which means ring. And the moon's shadow will sweep across Earth that day, but it'll be a special part of the shadow called the antumbra, made visible on February 17th because the moon will be in a far part of its orbit. And so on February 17th, observers inside the moon's antumbral shadow will see the ring of fire eclipse. And as with a total eclipse, you have to be in that shadow path to see it. Here's what astronauts aboard the International Space Station saw on May 20th, 2012, during an annular eclipse. The dark area is the moon's shadow. Greatest eclipse on February 17th takes place at 12:11 UTC. That's another reason that we in the Americas can't see it. For us, it's happening overnight on February 16th. And if you're just joining us, welcome. We're talking about the February 17th annular solar eclipse. And coming up next, the truth about those six-planet parade graphics that you may have seen circulating on social media. So stick around. What you see here is the path of the moon shadow on February 17th. The eclipse path is 2,700 miles or about 4,300 kilometers long, but it's very remote. It lies almost entirely in Antarctica and the surrounding Southern Ocean. Only a handful of spots on Earth's surface, mainly scientific research stations, will fall within the eclipse path. That includes this place, the Concordia Research Station, French-Italian station. And it also includes the Russian Mirny station in Queen Mary Land on the eastern part of the Antarctic continent. The primary American base in Antarctica is called McMurdo Station. McMurdo will see a deep partial eclipse with the sun 86% blotted out by the moon. And meanwhile, about 2% of Earth's 8.3 billion inhabitants, or a couple of 100 million people, will have access to the partial eclipse from the southern tip of South America and southern Africa. As always, you'll need eclipse glasses to see that eclipse. So if we can't see it in North America, why am I talking about it? Why do we in astronomy care about it? I can't speak for everyone, but here's how I feel. Whether or not you can see it, every eclipse is a great cosmic event. This animation is from the astronomy visualization master, Tony Dunn of San Francisco. It depicts our sun moving through our Milky Way galaxy with the planets, including Earth, spinning around the sun. We're on that innermost spinning part. And this is what I'll be thinking about on Eclipse Day We're riding on a planet that's whirling through space in orbit around a sun that's flying at more than 100 miles per second around the center of our Milky Way galaxy. And yet, somehow, in the midst of all this motion, worlds will align in space. And if you're like me and you want to think about this eclipse in real time while it's taking place, timeanddate.com has a great eclipse countdown page that'll show you the exact time at your location. That link is in the post notes. And just one more thing to think about, eclipses never happen alone. They always come in what are called eclipse seasons. So every solar eclipse, for example, falls within about 2 weeks of a lunar eclipse, and a total lunar eclipse will be visible from parts of North America and many other parts of the world on the night of March 2-3. I'm going to talk more about that toward the end of this stream, and I will be streaming about it and giving all the details soon. So click that subscribe button so you don't miss it. And now, about that 6-planet parade. Have you seen these images in your social media? They all mention a date, February 28th, and they all look a lot like this. They're eye-catching, but are they true? Here's Earth Skies, Marcy Curran, our Voice of the Night Sky here on YouTube, with the story.
I've been seeing a lot of memes and infographics online about C6 planets on February 28th, and I wanted to kind of cover what you can expect to see. This particular infographic shows that it starts at dawn, and one of the problems with this is Mars is the only planet visible in the morning sky at dawn, but it's so close to the sun, you probably won't see it. This infographic is showing the 6 planets align, and they're mentioning it's all on February 28th. Again, it mentions dawn, but the 6 planets are in the evening sky, and it shows Mars there instead of Mercury. So we're going to take a look at what you can see in the nighttime sky. This chart has some good information in it. To see Mercury and Venus, they are going to be really only visible in the evening twilight, so look about 30 to 40 minutes after sunset. Now, Saturn is going to start showing up around dusk or darkness. I think one of the reasons that everyone has picked February 28th for these infographics is because the moon is going to be near Jupiter that night. Here's Earth Sky's chart that will show the planets in the evening sky of February. And you can see Mercury and Venus are really low on the horizon. You can spot them in the evening twilight about 30 to 40 minutes after sunset. Saturn is going to be higher in the sky above the horizon, so look for them around dusk or as darkness falls. And of course, Jupiter is brighter than all stars, so you can see it as soon as the sky starts getting dark. And here's an Earth sky chart that actually is showing kind of the entire sky at mid to late February. You can see Jupiter is the brightest object in the night sky, and of course, Sirius is the brightest star. You can find it from using Orion. And again, look for Mercury and Venus in twilight and Saturn as darkness falls. The other 2 planets, Uranus and Neptune, you need optical aid to see those. And here's just kind of more of a close-up of what you can expect to see in the evening twilight. Now, one of the best ways to always find planets or stars is to follow our Earth Sky Night Sky Guide, and the moon will guide you to planets and stars. So one of the best nights to look for Mercury is going to be February 18th. Start looking for a slender crescent moon near the horizon about 20-30 minutes after sunset. And then on February 19th, that moon is going to move and be close to Saturn. And then you can look for the moon closest to Jupiter on the 26th and 27th, and it'll be near the twin stars of Gemini, Pollux, and Castor.
Marcy, thank you. So Marcy, those planets are already there, aren't they? They're already in the evening sky.
Yes, I'm lucky to live where I have a wide open western horizon, and I spotted Mercury and Venus last week.
So you saw Mercury and Venus, so that means Mercury, Venus, Saturn, and Jupiter are already in the evening sky. And Uranus and Neptune, I mean, the Neptune must be really in the twilight now and tough to see for that reason.
It is very near Venus from our point of view. So
Yeah.
it would be really tough to spot, even probably with a telescope, because it's so bright over there.
Yeah, I
And
was going to say that because some of those memes say that you can see Neptune with binoculars, but really,
not
probably, probably not. And to see Neptune or Uranus, you're going to need a star chart that
right,
shows, what the configuration of stars is
right,
in your binocular or your telescope view, and then which one of those dots
right.
is Uranus or Neptune. So they're not trivial to see. You've got to have some optical aid, and you've got to have a chart, which is
Right,
really like Marcy and I could not identify Uranus and Neptune
I
without optical aid and a chart. Like there's just no way to do it.
know.
Really, if Marcy and I ruled the world, what we would want is for everyone to be looking at the sky more often, because these planet parades have become kind of a thing in the past year or two. Like people are talking about planet parades, and trying to find these planet parades. And the one at the end of February it's just not, I mean, they're there, but it's not what's depicted on the memes. February 28th is neither here nor there. We don't know exactly. We think we know why they chose February 28th, but it's not. There's nothing special about that date. And you can see these planets. You can see most of the planets most of the time. Unless they're in the direction of the sun, they're somewhere in the
Right,
sky. And
right,
so we're all moving in these big orbits. So most of the time they're somewhere other than the direction of the
right.
sun. So they're in the sky. Most planets are in the sky for most of the year.
And technically, Mercury is going to be best around the 19th because it's going to be farthest from the evening sun that night.
This is a great time of year to see planets close to the sunset in the evening sky. And that just has to do with the tilt of the Earth and the path that the planets travel along, called the ecliptic. And it's more perpendicular to the horizon during the spring months. So from the northern hemisphere, right now, it's a good time to see planets near the sunset.
It sure is. And it's fun to be able to say, I've spotted elusive Mercury.
Absolutely, absolutely. This is a great time to look for elusive Mercury in the evening sky. Marcy, thank you so much.
Oh, you're welcome. I hope everybody gets out and spots the planets this month because it is always kind of fun to see them.
Okay, so that was Marcy and me. She wanted to be here live, but she couldn't be, so we recorded that a little earlier. She and I have been watching the sky for 50 years each. So a combined 100 years of skywatching expertise between us. And everybody on the Earth Sky team loves the night sky. And we hope you'll come to feel that too. So to learn what to watch from day to day, you can follow Marcy's short videos at Earth Sky's channel here on YouTube. And I want to open it up for questions. Okay, we got this question from Christopher Downing. I want to know more about the March 3rd blood moon. I've never gotten to see one live, only on video. I live in Salem, Oregon. Oh, you're in such a good place to see it. Hoping for clear skies. Yes. So the lunar eclipse, one thing that's really important, Christopher, about that lunar eclipse is that it doesn't happen the night of March 3rd. It happens the morning of March 3rd. So I don't know exactly the time in your time zone, but I think it peaks at something like 5 a.m. Central Time. So that would mean 3 a.m. your time. So you're going to have to be up in the wee hours to see that eclipse. It is a total lunar eclipse, which means that the moon will be entirely within the dark shadow of the Earth. And it's called a blood moon eclipse. It didn't used to be called that, but in recent years, people have taken to calling that, not because it has anything to do with blood, but because the shadow on the moon, sunlight filters through Earth's atmosphere, and it causes that shadow on the moon to have that reddish cast. So as I said, I'm going to stream about it sometime between now and the event. So please watch for that. Let's see. Somebody did ask, Natalia, I'm going to grab this one. Oops. Sorry, joined a bit late. Is it possible to see Neptune with binoculars? I've managed Uranus. Yeah, Marcy and I talked about that in the video a little bit. I would say no. Like I've never seen it through binoculars. You really do need a telescope to see Neptune. I mean, somebody out there is going to say to me, I saw it with my, super powerful binoculars mounted on a tripod with my, X years of experience or something like that. To see Uranus or Neptune, you've got to have binoculars for Uranus, probably a telescope for Neptune. But the most important thing you have to have beyond that optical aid is that you have to have a chart. So you can't just look up there and see them. And like I say, Marcy and I can't do that either. Like they're moving really slowly in front of the stars, but they just look like dots pretty much. So Uranus is kind of a greenish dot and Neptune is kind of a bluish dot, but there's lots of bluish dots up there. So yeah, you need a star chart and optical aid for Uranus and Neptune. There's only, I mean, when you see something like a 6-planet infographic and something saying you can see 6 planets, you got to remember there are only 5 bright planets. There are only 5 planets that we can see with the eye alone. So that's Mercury, Venus, Mars, Jupiter, Saturn. Those are the planets that we can see with the eye, and they're really bright. So yeah, those are easy to see. Uranus and Neptune, probably not. So someone asked this question. Will the explanation of the 6-planet lineup be available on your website? And we don't have it up there at this point, but that's a great idea. We do have a separate video coming out about it, and we'll put that video and some information into an article at earthsky.org. So please look for that. Thank you, you guys. Thank you so much for joining us. And I really appreciate you being here. One Earth, one sky, Earth Sky.